So at the end of last class, we started talking about the different levels of measurement, and there was a video on that, and we talked about the nominal level. I'm going to begin. We did a little bit of this for the ordinal level, where we assigned a ranking of productivity of employees, and the example we used was the ranking of 3 different brands of soft drinks. So before we go on, does anybody have any questions regarding whatever we covered in the last class? So you can use your microphone or you can use the chat. Any questions? No questions? Okay, we'll move on. So the example on the PowerPoint, if people are familiar with Aesop fables, of the race between the hare and the tortoise, and the hare finished first ahead of, sorry, the tortoise finished first ahead of the hare, and the ranking was 1. And the ranking for the hare was 2, because it was only a race between 2 animals, the hare and the tortoise. And remember, what you can learn from ordinal data is not only the ranking based on whatever measurement that you're looking at, but also you can look at the time, if that's what it's measured in, or you can look at it in terms of productivity from the example we did previously. So are there any questions about ordinal data? Remember, you can put up your hand or you can use your microphone. All right, so we're going to move on. So a lot of surveys, and some of you may have been involved, or all of you have been involved in doing a survey. This is an example of ordinal data in a survey where you can go from strongly agree to strongly disagree, and they're giving a value. Strongly agree is 1, and strongly disagree is 5. So remember, this is not telling you that 5 is better or 5 is worse than strongly agree. People are giving their opinions, and they're just assigned values. So it seems like a spectrum because it's going from strongly agree to strongly disagree, from positive to negative, but it could go the other way. So it really doesn't matter what you label the numbers, but it is somewhat continuous, going from positive to negative, go from negative to positive. Any questions about that? Let me just check the chat. Why are there 15 students in another room? Today is Tuesday the 15th. I'm not sure why. Okay, so no questions about that. We're going to talk about the interval level and the distances between consecutive integers are equal. And that's why it's referred to as the interval level. So there's no difference in between the levels. Previous example, when you had the survey, you don't know what the difference is between the levels. That's something that really you can't discern. You can't figure that out. And so the characteristics of the interval level is relative magnitude of numbers is meaningful, which means the larger the number, that can be translated into some kind of understanding on the reader's part. The differences between the numbers are comparable. There's a location of origin. 0 is arbitrary. The vertical intercept of a unit of measure transform function is not 0. So examples are, in our case, Celsius temperatures, calendar time, or monetary utility, so the value of money. Is there any questions about the interval level? We did go over it a little bit in the last class. No questions. Okay, everybody knows this. Great. Okay, now we come to the most complex level of measurement. And as I said previously, this is the one that most people do analysis on. And this is what most people understand. It's the sort of the easiest to understand, even though it's a more complex level of measurement. And the characteristics are the relative magnitude of numbers is meaningful, which means when you're comparing a very small number to a very large number, the large number has some kind of meaning because it is that much larger than the small number. The differences between numbers are comparable. There's a location of origin, and 0 is absolute. And the vertical intercept of a unit of measure transform function is 0. So examples are, you measure height, you measure your weight, you measure the volume in a test tube or a container or a cup or a glass or whatever. So an example can be monetary variables, such as profit and loss, revenues and expenses. And example is financial ratios, such as P over E. So does everybody understand the data that you're most likely to look at or be exposed to in your future career is probably going to be ratio level, unless of course you're doing a survey and you might be looking at frequency data. So does everybody understand about ratios? Yes, Amir Hossein. I am not sure why it's cut. I'm surprised at that myself, but when you look at the actual PowerPoint, you'll see the full PowerPoint slide. And remember, I mentioned that you can access all the PowerPoints. Okay, Amir, I will call you Amir. And why is it, and why do you measure time with ratio, or you measure the time with ratio? Is because you can do multiple or mathematical functions with ratio numbers. Okay, you can divide, multiply, add, subtract, and more complicated mathematical functions. So the usage potential of various levels of data. So think of it as a square. Ratio is on the outside, covering all this data. Then interval, which is a smaller box, ordinal, and then nominal, the lowest. So let me try to get the video of this. And let's see. Sorry, I have to go outside and then inside. God. I'm sorry, my internet is very, very slow. Oh dear.
Let's start by differentiating between quantitative and qualitative data. Quantitative data is information that can be counted or expressed as numbers. Since this data is numerical, it can be used in mathematical computations and statistical tests.
Okay, sorry about that. I'm going to try to get that from the beginning. Okay.
Let's start by differentiating between quantitative and qualitative data. Quantitative data is information that can be counted or expressed as numbers. Since this data is numerical, it can be used in mathematical computations and statistical tests. This is also the data you'll find presented visually in tables and graphs. Quantitative data can be categorized as either discrete or continuous. Discrete data is that which has a finite number of values, like the number of correct answers on an exam. If the exam has 20 questions, there can only be 20 correct answers. Or, another type of discrete data is that which has a space between a pair of values when visualized on a number line. For example, the number of pets owned is a whole number, 2 dogs or 3 fish. There is a space between 1 and 2 pets. In other words, you can't have 1.5 pets. Continuous data is that where the possible values fall on a continuum. Usually, continuous data is some sort of physical measure. The number of possibilities depends upon the accuracy of our measuring device. Age and height are both examples of continuous data. One general way to tell if data is continuous is to ask yourself if it is possible for the data to take on values that are fractions or decimals. If your answer is yes, this is usually continuous data. Quantitative data is very valuable, and much of public health relies on it for decision-making and evaluation. However, it is not without limitations. It cannot predict who will get disease and who will not. Usually, it will not give a solution on how to fix a problem, only identify that there is one. It can help in ranking problems, like disease burden or risk factor prevalence, but doesn't tell.
Sorry, I'm just going to stop there because it's very important. The data, when you look at data, it doesn't tell you, for example, predicting who's going to get the disease. It doesn't tell you how to fix a problem. What you have to do is to apply a statistical test to the data to answer those questions. So I want to make that clear. The data isn't going to tell you anything until you analyze it. So everybody clear with that? Okay.
Tell us which problems to address first. By itself, it is insufficient evidence to make a decision. Qualitative data continues where quantitative data leaves off. It is the data that describes, explains, and characterizes the subject of investigation using words rather than numbers. It generates the feel or texture of numerical data. It is often used to define a problem or generate new ideas for research or intervention. And it can be very useful to add to quantitative results of a program evaluation. There are several ways in which qualitative data are collected. Focus groups are a commonly used method for qualitative data collection. In this method, a group of people are asked about their attitudes and experience on a given topic. Questions are asked in an interactive group setting where the participants are free to talk with other group members. Typically, they are led by an experienced moderator. Other forms of qualitative data collection may be interviews with key informants, direct observation, or evaluating archival material like newspapers. Let's think through this example. Say you're interested in the opinions of diabetes program managers in how to market diabetes education to the target population. You may consider conducting key informant interviews with the 12 managers, or you can convene a focus group to capture the group thinking on this topic. This table juxtaposes quantitative and qualitative data. Quantitative studies events. It asks how many or how much. Qualitative studies motivation. It asks why. Quantitative is objective, more definitive, providing the proof. Qualitative is subjective. It is exploratory and interpretive.
Okay. So was that clear? Was that understandable? Yep. Okay. If some of you are going to work, say, in the marketing area, you will probably come up with survey questions, or as explained in the video, you might lead focus groups and ask people their opinions about some kind of topic. And video did say, when you're collecting qualitative data, it's somewhat subjective. However, as the person doing the research, you can try to make the questions as objective as possible because you want to reach the widest audience and you don't want to introduce researcher bias into the questions. Like, you do not want to be led by the researcher. You want the questions to be objective. And that results in the better data, or the cleaner data. So everybody good about that? Everybody understand that no matter what you're doing, you want to be as objective as possible when approaching data analysis. Okay, so this is just a summary of the types of operations and the statistical methods used. Nominal data, as we said, is about classifying and counting. And the statistical method is referred to as non-parametric. And parametric just says there's no parameters because you're asking for somebody's opinion. And therefore, you cannot define the parameters. Ordinal data is all of the above, plus ranking. It also uses non-parametric data, and I'll talk a little bit about that. Interval data are all of the above, plus addition, subtraction, multiplication, and division, and that uses parametric data analysis because there are parameters involved. And ratio data is all of the above and also uses parametric data. And I will just tell you, and I think I mentioned it in the last class, there are limitations with nominal and ordinal data because there are no parameters, and so you can only do so much with the data. With interval and ratio, you can do more analysis. You can make more inferences from the data analysis. So if you're going to use the data that's in the course, in the folder with the data that's available to you, that's all ratio data. I believe there's some nominal and ordinal data, but you can do much more analysis. You're going to select your own, and we're going to go over that if that's your choice. You have to decide what kind of measurements you want. You want to get as much as you can out of data. So it's best to try and have parametric data, continuous data. So is that clear? Has everybody got that? Yep. Okay, good. Okay, I'm going to briefly just talk about research and ethics. And this is from the Committee on Professional Ethics of the American Statistical Association from April 2016. So the ethical statistician uses methodology and data that are relevant and appropriate without favoritism or prejudice, and in a manner intended to produce valid, interpretable, and reproducible results. And the third one is probably the most important. If you do a data analysis, a proper data analysis, it's expected that anybody who is reading your report or reading a paper, and you may submit it for publication, that can be repeated. Okay? If it cannot be repeated, then it's not good data. Okay? Because there may be some subtlety that you personally use that someone else who's repeating your experiment or research doesn't understand. So the ethical statistician does not knowingly accept work for which he or she is not sufficiently qualified, is honest with the client about any limitation or expertise, and consults other statisticians when necessary or in doubt. So the example I gave in the last class about Cyril Burt, who was a psychologist who basically made up data because he didn't have enough access to children that he was testing. He just made it up, and nobody knew about it for 20 years. So because when somebody tried to replicate the analysis, they did not get the same results. So the second point, integrity of the data. And you're candid on any known or suspected limitations, defects, or biases in the data that may impact the integrity or reliability of the statistical analysis. Now, has anybody heard of the term outlier? No one? Okay. Yes? Yes? Okay. So it's sort of mixed. Okay, so say you're collecting data and you're doing the measurements. And usually, let's say 90% of your data looks like a normal curve, but there's 10% of the data that you can't explain the results. They may be either way out too high or way too low. And these are usually referred to as outliers. And there's some controversy on whether you should use that kind of data. Now, some people throw out the data if their sample size is sufficiently large. If they have thousands of observations, or, as we talked about, and we'll talk about it a little bit further on in the course about sample size. And usually a good sample size is 30, sort of the minimum number of observations. But if you have some outliers within that 30, and say it's 4 or 5, you want to increase the sample size, because if you take out those 4 or 5, or if you keep those 4 or 5 within the data, you may get skewed results, and they may be the incorrect results. So that's something to watch if you're going to use your own data set. And the third point is the statistician supports valid inferences, transparency, and good science in general, keeping interests of the public funder, client, or customer in mind. And the fourth is the research, the subjects, if you're surveying people, they cannot be fooled, they cannot be duped, they cannot be told one thing and something else happens, because they used to do those things because they'd never had an ethical committee, and people were told one thing and something else happened. It produced interesting results, but they don't do that anymore, or they're not supposed to do that anymore. And if you're working on a team, the team should be made of professionals with different professional standards, and you must know how to work ethically in this kind of environment. And the practice of statistics requires consideration of the entire range of possible explanations for observed phenomena, and distinct observers drawing on their own unique sets of experiences can arrive at different and potentially diverging judgments about the plausibility, the validity of the different explanations. And responsibilities regarding allegations. The ethical statistician understands the difference between questionable scientific practices and practices that constitute misconduct, avoids both, but knows how each should be handled. And the next one, responsibilities of the employers, including organizations. So you say you're working for a company, they want to do a survey. It's your job, and you have to be careful, and you don't want to, if you're doing a survey with people, you don't want to be, unscrupulous, and you don't want to deceive your potential subjects that you're going to interview or work with. And so it's responsibility of the employers to be sure that doing any kind of research is fair and equitable. Are there any questions about research ethics? No questions, okay. But what I'd like is for you to think about that when you are doing your data analysis. It's one thing to have data and throw out something that you don't particularly like. That's not real data analysis. As I said, we're talking about outliers. And of course, it also depends on your sample size. The data that I'm providing to you, I think the data sizes are adequate. I haven't checked them all. If you're going to do your own analysis, then we have to check the data. So that's very important if you're going to do your own. All right. Okay. So how many people have heard about data mining? Can you tell me what you think it is? Some people? Digging data. What does that mean, Song? Like digging in a mine. Okay, can you sort of expand on that? And how does that relate to data? When you're digging in a mine, what are you actually doing? Yeah, hunting for data. Okay. Data embedded in files not meant for people to know, but breaking down code to extract it. Sure. And digging for gold. In a way, yes. So, what you're doing is let's put it this way. When I was doing my thesis, my supervisor said, you want to get as much as you can out of the data, which means it's like if you go to a rock,
business activities.
a rock, you would think a rock doesn't have any water, okay? But there is water in the rock. And so you want to find as much water as you can possible in a rock. And it's like digging for gold. So I was told, get as much as you can from the data, because there are things in the data, there's attributes that you may not be aware of. And so you want to get as much as you can. And it also refers to like the size of the data. We now have millions of data points as opposed to previously, let's use the census data, there's millions, but there's also, let's say, 10,000 different kinds of variables. So there's lots of data that you can look at and extract information from that. So all of you are you have a little bit of everything there. So are you somewhat understanding what data mining is? We're not going to really do very much about data mining because we're not looking at big data sets. But has everybody got an understanding of what data mining is? Yep. Okay. All right, so I've got a little video to show about data mining. And again, I apologize for the time. And let's see if we can get that up and running. Okay.
In general, but it's kind of a
Oh, sorry, I'll start at the beginning.
the concept of data mining is growing in popularity in the realm of commerce, business activities in general. But it's kind of a misconceived or misunderstood topic. And I want to give you an idea of what data mining is all about. Basically, we're in the information economy. And what you have is more and more data being generated in every aspect you can think of. Every time you swipe your grocery card, when you try to get a discount for buying whatever products, that's data being downloaded to a database. On most transactions you do, there is some sort of data download. Organizations are storing, processing, and analyzing data more than any time in history, and that trend is going to continue to grow. So what is data mining? Data mining is the incorporation of quantitative methods, we'll call them mathematical methods, that may include mathematical equations, algorithms. Some of your prominent methodologies are traditional logistic regression, neural networks, segmentation classification, clustering. Those are all methods that utilize mathematics. Data mining is applicable across industry sectors. Generally, wherever you have processes, wherever you have data, it is the application of these powerful mathematical techniques in cooperation with some statistical type of inference testing, they call it, that will extract trends and patterns. And I teach a course at NJIT, Data Mining for Managers. I go over this. The first half of the course, I give students a very good understanding of what data mining is, because to be honest, many people don't quite understand it. So it takes a full half of the course to provide that understanding. What are these mathematical techniques? But just as important, the second half of the course, I say, now you understand these techniques, now let's use them in the business world. Let's apply it to advertising and marketing effectiveness. Let's apply it to e-commerce initiatives. Let's apply it to even healthcare processes, supply chain processes. There's just a number of businesses that can be mined with these techniques. Simply put, any organization where it has data and it has processes can be analyzed with data mining. And the results are extracting information, actionable information from these data resources that organizations can fine-tune their processes, increase productivity, and increase efficiency. So the data mining topic, this whole idea, the concept is going to grow in popularity. Why? Because data continues to grow. Think about social networking now, LinkedIn, Twitter, Facebook. What is it? It's more data, and it's data to describe people. what they do, what they like, who they are. When you're out buying or doing whatever, as far as using services, just conducting your daily lives, more and more there's data gathering and data capturing, and it's just the way it is. We're in the information economy. The way to extract strategic information from that data, those data resources, is with data mining.
Okay. So was that somewhat understandable? You guess? What did you not understand, John? Anybody else? Oh, you got lost. Okay. Basically, what he's saying is there's technology now that contains a lot of information. So, does everybody have a debit card? Okay. Yeah. All right. So there's a lot of information. So when you do a transaction with your debit card, what happens to that information? Can you think of where it goes? Okay. Stored in the cloud. Okay. But who's getting this data? Who is getting this info? Well, that's one place, to the bank. Okay. The sales rep, the bank, where whatever you bought goes to their office or their company. Okay. The bank is not going to do very much. Basically, they're looking at how many times you're using the card, how much you're spending, if you're going over your limit. But the store, they're looking at, oh, what is this person buying? How much does it cost? Where did they buy it? Is everybody is there anybody that has not bought anything on Amazon? Never. John has never bought anything on Amazon. Okay. I'll explain why. Say you buy something, okay, your sister. Say you're buying something, and we'll just use Amazon as an example. What's wrong, Ocean? Oh my God. Anyways, you use it every day. Okay. Well, there's a difference within the class. I buy something, object A. Okay? Object A is something. It has characteristics. Object A costs something. When it goes back to Amazon, they look at, Ocean buys object A. Okay? How much does object A cost? What is object A used for? Where does object A come from? And what they have done, does everybody know what an algorithm is? Yes, they up the price, right? Everybody knows what an algorithm, basically it's a formula. So they take the information based on what you have bought, have created a formula, stick the numbers in there, and then the next time, say you go to the website, there might be something on the website that says, oh, this might be of interest to you. I don't know if people have checked that out. Exactly, Brenda. They'll show you something that's related to it because they have plugged in the numbers based on your purchases and your searches to say, oh, you might have some interest in this. You don't necessarily have that. You don't really care about it. Right, Olga? They're trying to predict your next purchases because they're using their particular algorithms. Now, they may be incorrect. They may have nothing to do with really what you're interested in. It may have been a one-time purchase and you don't care. But that's what they're doing with the data. What they're trying to do is predict what you're going to purchase next, predict what you like to purchase, and maybe throw in something there. Well, if you buy this, you may get this for half price, or you may get this object for nothing. So they're looking a way to increase your spending, obviously, and they're looking for a way that they are going to capture you as one of their customers. And that's what you can do with data mining. So I'm just going to read a little bit here. Its foundation comprises 3 intertwined scientific disciplines: statistics, obviously, the number study of data relationships; artificial intelligence, human-like intelligence displayed by software. That is your, think like a human; and machine learning, algorithms that can learn from the data to make predictions. So they're trying to use your purchase history, and it's if you don't give cash to somebody, they don't know who you are. Okay? Oh, sorry. If you don't give cash, they will know exactly who you are. If you only give cash, they don't know who you are. And so there's an emphasis here on machine learning and big data. Let me get to the videos of that. And sorry. So has everybody heard or have you read the book called 1984? No. Okay. I know it's not English class, but I would recommend you reading 1984. Basically, it's where the government actually controls everything that you see, you do, and they're telling you what you have to buy because they know, well, but they're in more control than that. So you basically don't have a mind of your own. You don't think for yourself. Okay. So sorry about that. I'm just trying to get the video.
Let's look at how
Oh, that's weird. Okay. Sorry, people. I apologize.
network, a component of SAS visual data mining and machine learning, can help identify communities that exist within network structured data. Networks consist of nodes connected in pairs by links, and links may indicate directed or undirected connections between nodes. You can think of undirected links as permitting two-way connections, and directed links one-way. To represent two-way connections with directed links, you use pairs of links, say from A to B and from B to A. Networks contain either directed or undirected links, not a mix. Each link typically has a weight assigned to it. The weight designates the significance or magnitude of the flow across the link. We could be describing relationships between individual people or between companies or organizations. The links could represent phone calls, financial or legal transactions, and so on. We could be talking about links between books, research papers, or social media accounts that refer to each other in some way, references, citations, or retweets. Sometimes the data you're analyzing have a pure network structure, but it's more common to see network structures embedded in larger data. Extracting, exploring, and exploiting that structure can be enormously valuable as you try to learn more about the data. Proc Network contains 11 different types of network analysis algorithms that enable you to explore various aspects of network structure, how nodes group together into cliques or communities, the relative importance or centrality of individual nodes, how many nodes can be reached from any given starting node, and so on. How does Proc Network relate to other capabilities in SAS visual data mining and machine learning? It complements them very well because Proc Network's algorithms have a unique focus on connections, on communication, and on strategic influential positioning within a web of connections. Network analysis adds a great deal of value to data mining and machine learning. All three approaches strive to identify structure in data and information. Community detection is used with undirected networks. If you want to analyze a directed network, then you will need to convert directed links into undirected links first. There are many ways to process the link weights of A to B and B to A pairs of directed links during this process. For example, averaging the weights or adding them together. In community detection, the end result is that each node is assigned to exactly one community. The communities are detected by examining patterns among the links. Nodes within the same community are more densely connected than nodes in different communities. The weights on the links factor into these calculations. Modularity is the metric we use to assess how effectively a set of communities divides a network. The modularity is the weighted fraction of all links that are within any defined community, minus the weighted fraction of links that would be in the same communities if the links were randomly distributed among the nodes. Modularity measures how well community detection reflects the varying density of the weighted links in the network. Let's see what community we can detect in data on collaboration in physics research. In this example, each node in the network is a researcher, and a link represents collaboration between two researchers. There are almost 9,400 nodes and just over 24,000 links in this undirected network. If we run Proc Network with its default Louvain algorithm, it detects 58 communities with modularity just over 0.81, which is very good. A bar graph of the community sizes shows that one community has well over 800 nodes, another has over 400, and the rest are below 400. We'd like to even out the community sizes if we can. Proc Network provides two ways to reduce unusually large communities. The first option runs the community detection algorithm recursively, processing the largest communities repeatedly. For this network, what works best is the other choice, supplying a list of resolution values.
Okay, I'm going to stop there because I'm sure your brain's hurting from what he's talking about. We're not going to get into that much detail about data mining. Now, if you recall, I mentioned that SAS is a software that you can get on the apps anywhere. And I'm not expecting you, or you're not required to learn how to do SAS, and you can see that it looks pretty complex and pretty convoluted. It's not really if you dissect it properly. But understanding how to use this software will be certainly very helpful in the future if this is something that you're interested in, or the company you're going to work for, or even your own company. If you get big enough and have lots of clients, you may want to run kind of software like this. But as I said, this is just showing you, um, what can be done. And this is the way, as part of data mining. Any questions about that? No questions. Okay. Everyone, no. And this is the only occurrence where we're going to talk about data mining. So I'm sure you're very happy about that. If where the guy lives in a bubble and doesn't know it, yeah, right. Yeah. Okay. So why is it important? I'm sure most of you go, I haven't a clue. And so you've seen the staggering numbers. The volume of data produced is doubling every 2 years. Unstructured data alone makes up 90% of the digital universe. But more information does not necessarily mean more knowledge. Exactly. So it goes back to, irrelevant and relevant information. What's irrelevant? I don't know how many on Google, that they count how many times you click to go to a different site. I don't know if people are aware of that. And they've got all that data. And they say, oh, you know what? Larry clicks about 35 times to go to this site. Why does he go to this site? But they know every site that you're going to, and they have it in their archives. And they're going to figure out, what is he interested in? Where can we lead him to? What can we do? So this is the kind, they're looking for money, obviously. They're looking for you to become, yes, they track everything, okay? And sometimes it's what's referred to as invasive, like it's bothering you. Like, no, I don't want you to know all that stuff. But, we use technology and we're not the ones in control of it. And back to data mining. Data mining allows you to sift through all the chaotic and repetitive noise in your data. If you recall what I talked about noise, understanding what is relevant and then make good use of that information to assess likely outcomes, accelerate the pace of making informed decisions. I think that's an important one. I don't know how much acceleration occurs because you have to slug your way through all this data, and most of it is irrelevant to what you're looking at. And there's some links there. We're not going to look at those videos, but you can learn more about data mining and data mining from A to Z and how organized use predictive analytics. Okay, predictive analytics is what we're interested in. Can we predict something from the data that we have? So, any questions about that? About data mining? Okay. And I'm going to show you this one last video, give you somewhat of a clue about what's bad methodology. The methodology is the process in which you are going to collect the information and how you do it. And sorry, let me. Okay. Sorry, everybody.
But even under the new Common Core, even if they said 3 times 4 was 11, if they were able to explain their reasoning and explain how they came up with their answer really in words and in oral explanations, and they showed it in the picture, but they just got the final number wrong, we're really more focusing on the how and the
Why to
way.
be correct.
Mr. Landlord.
Yeah?
What are you smoking, an army blanket?
Never mind about that. You owe me room rent.
All right, here's $28.
$28, fine. Just a minute. You owe me 13 weeks at $7 a week, and that happens to be a lot more than $28.
Well, that comes to $28.
Did you go to school?
Yes, sir.
Do you mean to say that you can prove that 7 times 13 is 28?
Well, it's got to be. Certainly it is, because Mr. Rabbit and I, that's $28. That's what you get.
If you can prove it, I'll tell you what I'll do. I will give you the room rent for nothing.
You will?
But if you don't prove it, you owe me double the back rent. Is it a deal?
That's a deal.
Okay.
Do you happen to have any Crayola on there?
Crayola?
Never mind. I got it.
Oh, you have?
I got the Crayola. 7 into 28 is going to come out 13.
That's your way.
That's my way, and it's got to come out right. Now, first, I put down a 7.
Right?
Now, I'm going to divide the 7 into 28.
Yeah.
I put a 28 there.
Okay.
Isn't that cute? Now, here we go. 7 into 2. 7 will not go into 2.
It will not.
That's a very big 7 to push into that little bit of 2.
You say it is.
We ain't going to hurt that little 2, are we?
Of course you will.
So we take the 2, open your hand,
Yes.
and I put that 2 right there for safekeeping. But don't drop it and don't lose it. Now, 7 into 8.
Once.
I put the 1 over here, 1 over there. Now, we're going to carry the 7 because it's very big and it's getting heavy on my shoulders, and I'm going to drop the 7 under there. Now, 7 from 8
Is 1.
is 1. I put the 1 down there.
Mm-hmm.
Now it comes. Would you mind opening up your palm of your hand, please? I would like to use that 2. Open it up. Give me that 2. You've had it long enough. I'm going to put that 2 right there. Now, 7 into 21.
3 times.
That's right. 7 into 28. 13.
Wait a minute. You have to prove this even better than that. You can prove it very easily by multiplication.
You mean you want me to multiply it?
No, not multiply. Multiply. Multiply.
All right. Multiply it.
7 times 13 is 28. Go ahead.
Now, first, we got to put down a 13, right?
Right.
There's a 13.
Times 7.
Times 7.
Right.
7 weeks times 13, right? 7 times 3.
21.
21. 7 times 1.
7.
7. 7 and 1.
8.
And 2 to carry. And again.
Wait a minute. I'm still not convinced. There's one sure way of proving this. One sure way. And that's by addition.
You want me to addition it up?
I want you to put 13 7 times on that wall and then draw a line and add them up.
You want me to put down 13 7 times?
That's right.
That's got to come out right. There's 1, 2, 3, 4, 5, 6, 7.
Wait a minute. What's the idea of spreading them out like that?
Well, it looks like a flock of seagulls going to hit the electric poles. Now we're going to add them up, right?
All right, go ahead.
Here we go. 3, 6,
Wait a
9.
minute. Let me do the adding this time.
Good. Come out right.
Well,
A 3, a 6, a 9.
Just a minute. I will do adding. Then there'll be no mistake.
Yeah?
All right? $28 each. All right? Now,
Go ahead. You had it up. Go ahead.
3, 6, 9, 12, 15, 18, 21.
22, 23, 24, 25, 26, 27, 28.
Now, 25 divided by 5 is 5. You see, the 5 won't go into 2, will it? No. But 5 goes into 25 5 times, you see?
No, you're wrong, Billy. Now, I'm pretty good mathematician. Now, 5 into 25, 5 won't go into 2, will it?
No.
But 5 goes into 5 once. Now, we didn't use the 2 before, so we bring it down here. Now, 5 into 20 goes 4 times. There you are. 5 into 25 14.
No, look, Pa. Now, let me prove it to you now by multiplication. 5 times 5. 5 times 5 is 25.
Well, I'm surprised you're learning.
Huh?
I'm surprised that you're learning. Now I'll show you. 5 times 14 is 25. 5 times 4 is 20. 5 times 1 is 5. 25. That's it.
No, look, Ma. See, look, you're wrong there because I'll prove it to you. We'll put down 5 14s here. 14. There. Now I'll prove to you by addition that 5 14s is not 25. 4, 8, 12, 16, 20.
21, 22, 23, 24, 25. There you are. Better brush up, Billy. I don't want to see you lose.
You gave me too much money. Huh? Not going to cost all this. If you got 2 10s for a 5, just so happen to have it. That's it. Now. That's it, Fitz. I like her. She's a regular scout. That's why. That's a woman that knows her stuff. Just a minute. Right, what's wrong? Just a minute. $15 went south. You gave me a lot of your fast topic, and have you got 2 10 for 5? Me like I said, I give me 2 10 for 5 over there. Wait a minute, are you accusing me of cheating? No, but you got 2 10. Here's your 5. Give me back my 2 10s. Now get I mean, here's 2 10s. Give me a 5. You did it to me.
Yeah. Anyways, I don't know if you're familiar with those comedians, but you can imagine somebody doesn't understand their math. That you would consider probably bad methodology. Anyways, okay, so we have finished with chapter 1. And according to what I said originally, is that once we finish a chapter, I will set up the test for that particular chapter. But what I want to do is I want to ask everybody, I will give you a little question, whether you would like me to set up the test to begin today. And remember, I said it goes over 3 days, so you don't have to do it immediately. However, when you do the test, you have to do it in one sitting. So I'm just going to set this up and let's see how it works. No, it's not the assignment, John. It's the test. No, it's the test that I'm giving not every week, it's every chapter. Oh, sorry. Well, I'm trying this piece of software that's part of Collaborate. It's a poll, so I'm going to do that. And you just indicate when do you want to have the test. and it's supposed to show me the responses. And there's 25 of you or 24 of you in the class right now. I'd like everybody to respond. Correct, Brenda. Okay, 9 people have not responded, 8 people. No, John, I cannot. Yeah, if it's today, I will open it when the class is finished, so like around 5:30 or whatever, and it would go from Tuesday 5:30 to Thursday 5:30. Correct, Brenda. Okay, so at one sitting for test 1, you have approximately 2 hours. Okay, there's still 4 people that have not responded. Okay, those 4 people, you don't care when it is, I guess. Okay. We'll get into what it is. Okay. So it looks like the test I will release the test as of Friday. So it'll be around, let's say 5:30. So you have Friday, Saturday, and Sunday. So Friday, 5:30 to 5:30 Saturday morning, Saturday 5:30 to Saturday 5:30 in the evening, and Saturday 5:30 in the evening. Explain, Brenda. Okay. Yeah. Okay. So I will release the test. So is everybody familiar with the test on Blackboard? Is anybody not familiar with doing a test on Blackboard? Okay, so you're all good. And as I explained previously, you have to do it in one sitting. You only have one opportunity to do it. And this brings me to yes, the test is on Blackboard. Okay. So I'm going to let me go here. I'm just going to go and show you where it is. No, I didn't say it was in my lab. I never said, are the tests available to you on MathLab graded? Yeah, there's interactive tests that you can do on your own and you can receive a grade for that. I'll show you, we'll get into that. And Ocean, what do you do when you assume something? Yes, you're assuming, that means you're not clear. For clarification, exactly. Sorry, everybody. No, I didn't say that, Mihak, did I? I didn't tell you what it is. Okay. Before you speculate, ask. Okay, so the test, and I mentioned this, I believe, in the first class. And what makes it difficult is because in statistics, there's going to be lots of formulas. My intention is for you to understand what the formula does, not to give me the formula and figure out the answer. We may do that later on, but what I want you to understand are the concepts. So basically, it's going to be a combination of multiple choice and true and false. All right. Now, is there anybody in the class that has not registered on MyLab? Everybody in the class today has registered for MyLab? Okay. Good. All right. Great. Well, let me just okay. Whoops. Nope. All right. I'm trying to get the oh, there. Okay. So this is the home page for the course, if you recall, and those are the folders. Okay, and there's a folder for chapter tests, and right now the test is hidden, so you can't see it, but that is where you will find the test. And so Friday, let's say between 5:30 and 6 p.m., the test will become available. And then it will become available for 3 days. Okay? And you must do it in one sitting. So set aside some time so that you can see and be comfortable to do the test in the allotted time. I'm not saying it's going to take 2 hours, but that's how much time I allotted for the test. So is that clear where the test is? So that's correct. No more chances after one sitting. Okay, where do you want to focus? Definitely look at the PowerPoints and the book. So that's both. Okay, yes, chapter 1. I don't remember how many questions, but you will have sufficient time to do the questions. All right. It's only one attempt. Yep. Oh, sorry. I'm sorry, I'm just trying to get back into I want to show you, if you haven't done this already, to go to Pearson. Okay, so this is Pearson's My Lab and Mastering. If I click on My Lab and Mastering Course Home, oh, that's interesting. Okay, I couldn't open, whatever. Ah, dear. Sorry for being so slow. Okay, so when you go into Pearson, on the left-hand side, you'll see a menu. Okay, what I want you to do is go to the chapter contents. And you want to go to chapter 1. Anyways, never mind this error. We're sorry an error has occurred. I think I was in too long. So each of the sections are covered, what we covered in the PowerPoint. There are some little interactive quizzes that you can test yourself on. And my recommendation is go through them and go through the text. This is the text, and you can look at the chapter per se. And there shouldn't be any surprises with regards to the test. And remember, this is statistics. So, you know, if everybody does poorly, I can alter the value of the test. So since nobody has said they don't have access, I recommend that you go through this in My Lab Statistics and test yourself. So are there any questions about
For each, sorry, sir.
from anything from chapter 1? Sorry, go ahead.
For each chapter, there's a pre-test one and a post-test.
Yeah.
So are any of the tests, pre-test or post-test, graded and part of our final result, like grade,
No.
or is it just a grade that's provided at the moment?
No, that's a grade provided to you.
Okay, perfect. Thank you.
Okay. Now, in the future, because there was some problems getting everybody to My Lab and problems with Pearson, in the future, what I may do it, I may not do it, is to give you some of the homework assignments that they have on My Lab Statistics that you can send to me, and I'll decide whether there's some value in that and we can add to it, because once you learn about statistics, you can learn to, you know, alter and change things. So I'm not adverse to changing something, because if you do poorly, I don't want anybody to do poorly, because that means that you're having difficulty understanding the concepts. So maybe doing the homework, and I haven't decided yet, maybe doing some homework assignments and handing them in will make up for a poor mark or poor grade. So any questions about the test? Speak now. No. Ocean doesn't have a question. Does anybody else have a question? No. Brissa, no questions. Okay. It seems no. So, all right. So everybody seems to understand chapter 1. I didn't say that, John. John asked if I'll change the weight. Okay. I want you to, part of the course is learning how to ask the appropriate questions in a statistical perspective. Okay. Don't make assumptions about what I'm going to do. No. Samar is asked about if there's any assignments or homework to do. The major assignment is the case study. But as I just said, I'm going to look at the chapters and probably assign some homework from my lab that you can send to me. And if you're doing poorly in one of the tests or a couple of the tests, I can look at the homework assignments as makeup for that. So is that clear? Okay. Yeah, to boost your marks up if you're not doing well. Okay. When is the proposal due? I don't know. When do you want? Monday? Okay, let's see. So we have 14 weeks in the term. I will say that if you can give me a draft before intercession, which is the 7th week, and I don't have my schedule in front of me, so I'm not sure. It's probably, I think intercession is October the 26th. If you can get something to me, or let's put it this way, the latest I would take your proposal is probably during intercession week. I don't want to push it to that because I want to give you my response and you can work on that. And remember what I said. If you would like to work on some other data that you know of, or you're very ambitious and you want to collect your own data, my suggestion is to discuss that with me earlier rather than later, because we talked about research design and how important that is in collecting the appropriate data and the valid data. All right. So certainly between now and hopefully you hand it in early. The earlier the better, because then you'll get back my response, and your proposal is also graded as part of the case study. So I don't want you to just slap it together, some copy and paste. And I want you to put some thought in it, because I'm hoping that everybody here is trying to get their head around thinking statistically. It's basically thinking rationally and logically, because that's how you should approach data analysis, or collecting data, evaluating data, presenting the data. I mean, the 4 main aspects of data collection is, collecting or identifying the source of the data. The MEHAC, the template is in one of the folders called the case studies. So, where are you going to get your data from? The data source. All right. You collect the data. If it's the source from government, educational institutions, or newspapers, then you don't really have to check the validity. But as I said, I want to look at what data you want to analyze, and then you analyze the data, and I will help you if you're not sure what you want to do, and you present the results, and then you present your conclusions, which is basically what inferences you draw from the data analysis. So you're really practicing appropriate research methodology. So are there any questions about that? No question from Ocean. Anybody else? Nope. Right now, at least. Okay. Nope. Oh, Amir, maximum 2 students per group. Right, John? Okay. So we have about 15 minutes. I just want to start chapter 2. I'm just trying to load up the file. I hope everybody's internet is better than mine, because mine is extremely slow. And just to let you know, I am doing my own data analysis, and I'm like publishing my own books. It's sports data, and if you'd like to look at that data, that would be fine. Except I think I have like 10,000 data points, so I don't think you want to look at that one. Okay. All right. So chapter 2. Chapter 2 is about frequency tables, frequency distributions, and graphic presentations. So let me ask the class, did anybody do any of this in any of their previous classes, math or economics? Ahmed, you did not? Neither math or economics? Mohammed? No, you didn't do this in math. Oh, you did do it in math. You did it in economics? Okay. All right. So can someone, you can use your microphone if you want, or you can use the chat. Can someone tell me what a frequency is? No one? The number of times. The number of times of what, Ocean? The number, Jatin? Is that correct pronunciation? The number of times something occurs. Right. So, can someone give me an example of a frequency? Anybody? Doesn't have to be a scientific one. This is frequency. What kind of data is that when we're measuring it? Okay, so Wellington, what do you mean times of the TTC? I don't not understand that one.
It's the times that the TCC comes on the to have the people, you know. So like one TCC, and then after 20 minutes another TCC, and
You
then
mean their schedule?
schedule. Yes, thank you.
Okay, so I'm going to emphasize this, and sorry if it's irritating, but we're talking about data, we're talking about analysis. You have to be extremely precise when you're talking about it. Times of the TTC, you're asking me to interpret what that means. So do you understand what I'm saying? You're
Yes,
talking
sure.
about their schedule, the schedule of TT, the schedule of the TTC. Okay, now I know what you're talking about.
Yes, sure.
Okay, so I want everybody to think that way. Right. Okay, so I'm just reading through these. I respond 7 times or more every class. There's 5 homes between 200,000, 500,000 in listing. So Amir, you could probably make that a little more specific when the class is given. Yes, this class frequency is 2 times a week, for example. Right. Okay. So I want everybody to understand a frequency is a count. We're counting whatever we're observing or measuring. Okay. So it can be anything. So if you recall in the last class, I talked about, we're going to look at all the students at George Brown. We're going to look at their hair color. So I don't know, what is there? 10,000 students at George Brown? Am I off? I'm not sure. So let's say 10,000. So we say 6,000, all the campuses, Brenda. I'm not sure. So say for all the campuses, there's 10,000 students, and we say 6,000 have brown hair. 3,000 have blonde hair, and 1,000 have red hair. So what can you infer? What can you extract out of that information? Anybody? So we have 6, 3, and 1. Can you say anything about that? 6,000 people have brown hair, 3,000 people have blonde hair, and 1,000 have red hair. Nobody? Well, can't we say that 60% of the people who attend George Brown have brown hair? We can say that. Correct. 60% have brown hair. 30% have blonde hair, and 10% have red hair. So I want you to realize that even if it's a frequency, you can still extract important information. Yeah, Ocean, it's a ratio. You get 6, 3, 1. Okay, good. That's very good. All right. So that's the ratio of hair color at the George Brown campus. Okay. Whether it has any influence on anything, that's another story. Not really, but we know what the count is. And that's basically what a frequency is doing. You're understanding what the frequency of some kind of observable measurement is occurring for some particular condition. So everybody gets the idea of a frequency. Anybody have any problems with understanding what frequencies are? Okay. So, and a frequency distribution, what is that? If we use the hair example, what is the distribution? Ocean, you've already submitted it. 6, 3, and 1. 6 for brown, 3 for blonde, and 1 for red. Okay, That's the distribution of hair color across the George Brown, all the George Brown College. So we don't have to get into whatever the campuses are. So does everybody understand that? That's what the distribution. How is it distributed? It's based on the categories that, if you are the researcher, you are the person that actually comes up with the categories. And remember what I said. You have to take into account all the categories. Now, for the hair color, it can be debatable because we could say, okay, that's 10,000 people, but maybe there's, 200 people that prefer to shave their head. Okay, should they be accounted for in the frequency distribution? Anybody? Right? Okay, so tell me, Ocean, why they should be counted in this frequency distribution. And Brenda or Ocean, why should the bald people, or the bald people, shaved head people, because they're students, correct. So they're part of the George Brown community, and this is where you, as the researcher, says, well, I have to count them. They're still students, right? They have to be put in there. They don't fit under those other categories, so I have to add a category. Correct, Brenda. They're part of the chosen population, and this is where when you are looking at data, you have to look at, you want to include all the data, whether it's, 10 categories or 2 categories. And even if there's a small number, you handle that afterwards. As part of the initial data collection, you want to get all the data, so that it becomes very important. Now, has everybody, I'm gonna use the example of Excel. Has everybody used Excel to produce charts? Yeah. Yep. Okay, great. So you know how to produce charts in Excel. And I'm not saying pick one or the other. And as I said, obviously you're very busy with the other courses. And if you want later on, maybe during the office hours, if there's not a lot of questions, I can do a little presentation of using SPSS and SAS. They're much more powerful than Excel. I mean, Excel is fine for introductory stats, but if you're going to pursue using statistics, probably understanding either one SAS or SPSS is very helpful. Okay, so everybody seems to be understanding about frequencies. So what we're doing is we're organizing qualitative data, right? Categories, that's also qualitative data, into a frequency table. You present a frequency table as a bar chart, a pie chart, or a stem and leaf diagram, and we'll go through those. And you organize quantitative data into a frequency distribution, okay? And you present a frequency distribution for quantitative data using histograms, frequency polygons, and cumulative frequency polygons. And remember, what you're doing with quantitative data is it is continuous, and qualitative data is discrete. Okay? So carrying on with the quantitative data, you also can use line charts and scatter diagrams. So I'm just going to ask this question. What's the purpose of presenting tables or charts? What does it do in terms of the data? right? It's easier to read. A visual aspect, what does that mean? Can you say more about that, Ocean? To understand more clearly? And why is that, Roshani? How do I understand more clearly? When somebody presents you with a visual representation of the data, what is that presented to the viewer of the data? It's eye appealing, okay? You mean it's like pretty? And Ocean, you're seeing the difference rather than the number, right? Has everybody heard the term "a picture's worth 1,000 words"? Or maybe that's way too old. I don't know. Okay. What it means is, as people have indicated, when I see a visual representation of data, for some people, it's way easier to quickly identify, what's the data doing? What does this mean? So you get a better idea in your head, and the presentation, depending on how well it's done, will give you, as somebody mentioned, a clearer idea of where the data is going. Okay? What is it? It's going up and down. It's going straight up. It's going straight down. Way in your head as the viewer, you're understanding this much better. And think about it. And I don't know if you've done this in any other classes where you might do a presentation and you're showing a diagram, and the rest of the class goes, oh, okay, now I understand. So creating a visual representation of the data is a much better way of explaining the data to an audience. You're working at a company, you analyze the data for, the VP or the CIO or whatever, and you're not going to present a lot of tables with numbers. You're going to present a visual representation. And right, Brenda, it's easy to compare results, especially if there's a big number of data collected. So get in the habit of, when you're looking at data, how best it is to represent that data visually, okay? And so you want to become a little more competent in producing whatever visual representation, whether it's a bar chart, a pie chart, frequency distributions, whatever. That way your audience catch on immediately. And when you're doing a report, you want to do that almost immediately, because then they're starting off on the same page that you are. So everything clear about, doing a visual representation of data. Okay. Okay, we're going to finish, and I'll just remind people that I'm going to do the office hours tomorrow. Nobody came to yesterday's office hours. I guess that means everybody understands what we've done so far, and you don't have any questions. Remember, you don't have to ask, questions specifically about any concepts. You can ask about the assignment or the tests or whatever. Okay. So everybody have a okay, John. So everybody have a good evening. And for those of you who are going to come to the session, it will be at 10 a.m. and you can see that on the Collaborate. And I encourage everybody to go to my lab and look at the chapters and look at the chapter reviews and the interactive quizzes. Okay? So Everybody have a good evening. Take care, and thank you. And we'll see you maybe tomorrow, but for sure on Friday. Okay? All right. Take care.